This is question 20. Here we're asked to prove algebraically that the difference between the squares of any two consecutive integers is equal to the sum of these two integers. First thing that we're going to need to do is we're going to need to define what is meant by two consecutive integers. And we're going to have to define these algebraically. So what I'm going to say is that, consecutive integers, that just means numbers which follow each other. For example, 2 and 3, or 8 and 9. So just any two numbers which follow each other. So what I'm going to say is that my first number is going to be n, and then the number which follows it will be n plus 1. So I've just defined algebraically two consecutive integers. Then what we need to work out is we need to work out the difference between the squares of these two consecutive integers. So I'm going to have to take the square of n plus 1, and I'm going to have to subtract from that the square of n, because the square of n plus 1 will be larger than the square of just n. So I'm going to take n plus 1, and I need to work out the difference of the squares. So I'm going to take n plus 1 and I'm going to square it, and from that I'm going to subtract the first number, n, that number squared, so n squared. Now, n squared, that's nice and straightforward. N plus 1 squared, well, I'm going to have to do a little bit of work here. What I should see is that I've got a bracket that has been squared, and so what I'm saying is that this means that this is n plus 1 multiplied by n plus 1. Minus n squared still. Working this out, so working out what n plus 1 multiplied by n plus 1 would be, I'm going to use a grid to work this out, and I'm going to times n plus 1 by n plus 1. N multiplied by n will give me n squared. N multiplied by 1 gives me positive n. N multiplied by 1 gives me n as well. And then 1 multiplied by 1 just gives me 1. So now I can say that this term here, n plus 1 all squared, I'm going to write as n squared plus 2n plus 1 minus n squared. So that is an expression for the difference between the squares of two consecutive integers, n squared plus 2n plus 1 minus n squared. And what we need to show is that that will be equal to the sum of these two integers. So the sum of these two integers, well, that just means that I'm going to take my first number, which was n, and the number which follows it, n plus 1, and add them together. So that means that this is going to be n plus 1. Okay, so this is the sum of the two integers here, and this bit of working that I've done over here, this is the difference of the squares. So sum of the integers is n plus 1. Difference of the squares is n squared plus 2n plus 1 minus n squared. Now, as you can see, all that's left for me to do is to tidy up these two expressions. I've got n squared minus n squared. So they are going to cancel each other out, and that just leaves me with 2n squared, just 2n plus 1. So a simplified expression for the difference of the two squares of n and n plus 1 gives me 2n plus 1. And tidying this up, the sum of the integers, well, that will be n plus n, which gives me 2n, and then that plus 1 on the end. And so what I have done is I have shown algebraically that, and I have proven this algebraically, that the difference between the squares of any two consecutive integers is equal to the sum of these two integers.